Hello everyone. So today I'm going to explain about my latest project that was e-commerce customer satisfaction score prediction model. Here I have used ANN model. So I have used deep learning technique here. So basically, like customer satisfaction is a crucial factor in the e-commerce sector. So that is directly impacting the customer loyalty, customer retention, like how they can they will purchase again on that retail stores. So yeah, our project goal is to predict the customer satisfaction score using deep learning ANN model. So like analyzing customers in their interaction and feedback in essential improving service quality, driving customer retention and supporting business growth. So without wasting time, let's start with our code. So here basically I have imported all the libraries that are required for our project. So this is the as usual part like dataset loading. I have like imported my data from the Google Drive. So here's the glimpse of the data. You can see many NN values are there. So these are the columns. You can see yeah, here also unique ID, channel name, subcategory, customer remarks. So this is the shape of the data set. So we have more than 85K plus rows and 20 columns. So let's see the like simple info regarding the data set. So you can see among 20 columns, like most of the columns are basically object data type, and only the item price and connected handling time has like float data type. We can see we like some columns have null values also, like order date time, and also connected handling time has like more than 90%, I would say, null values. So we'll see in the further steps how we can like how we have handled it. So so I have checked for duplicated values also. It is coming as 0, so it means like no duplicate values are present. So here I have checked for null values. You can see like for connected handling time we have already checked. Like I told you that 90% more than 90% values are null. So you can see here this is the distribution of the null values. So these are the columns here, and I have uh, find it out here the statistical summary of all the features. So I would say so here unique ID and category, all the numerical and object, all the columns like statistical summary I have presented here. This is basically a data set description. So we have channel name. So channel name basically representing the service channel, name of the customer service channel, and category means the category of the interaction. Okay. And a subcategory means subcategory of the instruction, like unique subcategories. Like under that category, the subcategories are coming. So customer remarks mean the feedbacks that we are getting from the customers. Order ID unique orders, unique order ID to get like identifier of the unique orders. Order date time basically date and time of the order. Issue reported at like timestamp when the like customer raised the issue, and issue responded means when the like associates like service associates, customer associates are responding to that issue. So survey response date of the customer service response, and product category of the project. So this is the item price, means the price of the item. Connected handling time, like time taken to handle the interaction with the customer. Supervisor, like name of the supervisor who has picked the call. And manager, like name of the manager who has who the supervisor's manager. I would say tenure bucket means bucket categorizing agent tenure on that company. And agent shift, that agent is working on which shift. And CSAT score, this is our target feature. Basically five, like there are total five ratings, like 1, 2, 3, 4, 5. So here we are checking unique values. You can see these are the values so like in unique ID, like unique ID it should be unique only. Channel name, there are three unique values are present, like that I have represented for all other features. So let's start with the data pre-processing part. uh, so first of all, I have checked the missing values. Oh yeah, already checked earlier. So here basically we did the like filled the missing values which are object type with mode values, and for the numerical and float values, like we have used median to fill the null values. And then for the say for our own like adjustment, like own ease, we have created a copy version of the dataset so that if we face any issues or something, so that our original dataset can be intact, we can use that in further steps if we face any issues. So here basically order ID, it won't create any impact in our analysis, so we can drop it. So like like irrelevant features, it like we can drop it. It won't create any impact in our project. So we have dropped it. And for the customer remarks, so there are numerous amount of the null values over there. So we have filled it with no review, means like where the blank rows are present, we thought that that customer has not given review remarks, that they have not added remarks, so that I have filled with no review. Here also, like the customer city and product category, wherever the missing values are there, we have filled with unknown. And item price, basically we have filled it with using median, and order date time we have converted into the date time variable. And here connected handling time, we have more than 90% null values are there, but connected handling time in the CSAT prediction model is it can create an impact. So it is a important feature for our analysis. So here we have taken it, but in few further steps, what I've done, let's see. But in place of this, you can create a hash handling time like that, like indicator variable, indicator feature, which can be represented by the Boolean value. Like if there is some handling time, then it can be 1. If there is not, then we can 0. We can do like that also. But I have used this connected handling time and filled all the missing values with min. So after pre-processing, you can see there are no missing values are present. So after pre-processing, this is the overview of the data set. So now start with the exploratory data analysis part. So I will not spend more time on this because the project code is too much. So we have to cover the main parts also, like VIF part and the feature pre-processing, feature selection, and the model building, the main part model building. So we will see only the main important EDAs, EDA part. So here basically this is the distribution of the CSAT score. So we can see the rating 5 has more rows. So more rows are basically based on the rating 5. So by seeing this distribution, you can easily understand the data set is imbalance. It is imbalanced. So before proceeding with the model building, we have to adjust this also. So in further step, I will explain how I have adjusted that part. So let's see, this is the category feature analysis, basically channel versus CSAT. So there are 3 unique channels are there, outfall, inbound, and email. For inbound, you can see the rating 5 is more as compared to other channels. So this channel, inbound channel, is basically the important channel, I would say. And basically in that channel only, we are getting more number of 5 ratings. So this is the agent seat versus CSAT. So the agents who are working in different shifts, based on their calls and response time, we are getting this CSAT score. So I would say in the morning, the customer interaction is more. So that's why maybe CSAT is more in the morning shifts. So these are the numerical feature distribution. So this is the top 5 product categories by customer satisfaction score. So in the electronic score, customer satisfaction score is high. Okay, so let's see. This is the same thing, like the top 5 categories, but these categories is basically the queries, like order related category or return related query. Those things I have represented. So basically, the return related, customer satisfaction score was high, means the whoever is raised a concern or complaint regarding the return related, they have given more than they are more satisfied than other related categories, I would say. So this is a subcategory with highest customer satisfaction score. So this is the This is the sub part of the category. So under that written, how many, how like there are different types of subcategories. So for the reverse pickup inquiry, the satisfaction score is high as compared to other subcategories. So this is the top 5 cities with highest customer satisfaction score. You can see for Hyderabad, the CSAT score is high. So Hyderabad, basically customer satisfaction score is high. So here I have represented the top 3 manager with highest customer satisfaction score. So John Speed got the highest satisfaction score. These are the agents. So Wendy Taylor got highest satisfaction scores. So let's see top peak performing supervisor. So here Carter Park got the highest satisfaction scores. So basically, this is the top 3 10-year groups with highest customer satisfaction score. So the employee who are like staying in the company more than 90 days, they are getting lots of like most of the customer satisfaction count. So here is a like chart you can see. The who are in job training, they are getting the second highest number of satisfaction score. Let's see in the other part. So top 10 agents by average response time. So Christian Castro got the highest like average response time in seconds. So she has done a great job, I would say. So CSAT score versus the item price. So basically the like customer satisfaction score, when the customer satisfaction score is low, then I would say the item price is high. And for where the like item price is less, there basically we got customer satisfaction as high as compared to other item prices. So now basically we will go into the outlier part. So before going into the outlier part, we have to check like the feature which are symmetric, like which features are symmetric, which feature are skewed. So for that, we did like that, like like we know, like if before outlier treatment, we need to see what are symmetric, what are skewed. Because basically, in case of symmetric, the mean nearly equals to median. So in that case, we can easily apply IQR method or the standard based standard deviation based outlier treatment. And but for the skewed, we have to use that mean plus C standard deviation, means the empirical rule. We know like whatever feature points are coming outside of the hard standard deviation of the graph, those we can treat as the outliers. So accordingly, we have identified the symmetric distributed features is connected handling time, and skewed features is item price and response time. So accordingly, we have treated. So after we have treated these things. So after treating, this is the feature like charts, like box plot, and the this is the histograms. After that, we proceed with the hypothesis testing part. So our first hypothesis was like CSAT versus channel name. So here, as both are categorical features, we have employed chi-square test. So we use like chi-square test of independence to check if they are related. So our null hypothesis was CSAT score is independent of the channel name. So we have we have checked like is that CSO score is the independent like dependent on the channel name or independent. So our null hypothesis was independent of the channel name, and the alternate hypothesis will be CSAT score depends on the channel name. So after doing it, we got the this is the test result. Chi2 statistics I got around 200, and p value we got so we got is less than 0, less than 0.05. So it's so we have to reject the null hypothesis. So it means CSAT depends on the channel name. Can see I have added the conclusion also. Since p value is less than 0.05, we have rejected the null hypothesis. So we can employ that, like we can decide, we can like see that that the CSAT score is significantly depends on the service channel. Okay, our test was CSAT versus customer type. So in that case, our null hypothesis was CSAT score is independent of customer type, and alternative hypothesis CSAT score depends on the customer type. So here also we got around like a p value is less than 0.05. So we have to reject the null hypothesis. It means the CSAT score depends on the customer type also. So this was the third hypothesis, effect of item price on CSAT. So our null hypothesis was item price does not affect CSAT. So higher item price increases likelihood of CSAT less than 3. That was the alternative hypothesis. So after like checking it, after like performing the Z test, we got the like the p value as z dash p value is less than 0.05. So we have accordingly rejected the hypothesis. High priced item significantly increases CSAT, means we have to accept the alternate hypothesis, means that if the item price is high, then it significantly affect the CSAT score. So if for the high priced item significantly increases CSAT less than 3. Again, we did some like feature engineering, like we have started with the categorical encoding part. So here we have dropped unique ID as well, because we want to create an impact in the our like model. So we have dropped that. So the date time column, so like order date time, issue reported, issue responded, survey response date. We have already we have extracted day, month, and hour and weekday from those columns, and dropped all the original columns. So after that, we have defined the low cardinality and high cardinality columns. Like high cardinality columns means agent name, means there can be more than 10 or 15 unique values in the agent name, supervisor, and the manager, as well as the customer city as well. But customer city, I've tried with high cardinality, but in customer city, I can use frequency mapping as well. But in that case, a model, I don't think the model will get that like important features, important learning part from the customer city. So that's why I've considered it on the low cardinality features. And for low cardinality features, I have employed one hot encoding, and for high cardinality features, I have employed level encoding. So here, so I said no, like that just now, that we can employ frequency encoding as well for customer city. So this is the code I have tried, but in that case, I am not getting that much of accuracy and the model performance. That's why I have considered that in the low cardinality and did the like one hour encoding. So after doing that, like we have a customer feedback, customer remarks column. So there we have like too many, I would say, like text things. So in that case, I have employed text features encoding using TF-IDI. Also, I have kept only top 100 keywords. I don't have like taken like more than 100. So that's why I have employed like these TF-IDI features, and I've encoded the categorical column. So after encoding, this is the like overview of the columns. After that, I did the feature manipulation. So from the response time, that response time we have. So we have like converted it into the total seconds. And after doing it, after categorical encoding and feature manipulation, this is the shape of our data set. So 85,907 rows are present and 1992 columns are present. And after as we have already did the encoding part, so we can drop the original columns. So here we have dropped response time and customer remarks. So after that, I've done the feature selection part. So this is the important part before building the model. So here I have first of all we have employed the dropping constant and quasi-constant features. So here you can see, I first of all I have like separated the numerical data, and I said we already set the threshold as 0.05. So if that like we have accordingly we have checked and dropped all the like column who has like variance threshold as variance threshold less than 0.05. So a number of low variance columns, you can see this is 104. So these are the drop column. Here basically variance we got very less than 0.05. So I would say like those model can't add any value in the model. So we can easily drop those columns as like we know like as we are employing deep learning and my my machine's RAM is also only 16 GB. So it's better to like remove all the irrelevant columns. And here basically by using the variance threshold, like we have removed the constant features as well. And after that, I have checked for the multicollinearity VIF. So basically, for the features which are VIF values are greater than 5 or 10, that indicates high multicollinearity. So high multicollinear features, we it's better to drop from our model build from our data set, because it can create confusion, like so model can't learn properly. It can create the overfitting as well. Yeah, so it's better to remove all the columns that have VI greater than 5 or 10. So here after checking it, we can see order date time CT, and these things are very high VI. So first of all, we have dropped all those things. You can see here I have dropped all those columns who has like what has the like, highest number of VIF values. So after doing it, I did the I did the uh, transformation part basically. So I first of all I have selected only the continuous features, and I have applied the transformation, iterative transformation. So this is the transformation I have applied. So and also I've created a function to check symmetry or not. If it's not symmetry, then it will again apply transformation. So after transformation, this is the distribution of our dataset. It's lot of improvement happened on the dataset. Again, like we have like divide the dataset into X and Y. Like we have separated the target variable and our main data. So and after that we have applied standard scaler on the continuous features. So after applying continuous features, this is the like you can see it's the uh, overview of the data. So only the continuous features related columns we have applied standard scalar, not the encoded features. Because if we apply standard scalar on the encoded features, it can like the info part can be vanished. Like it can't create any impact on the model. So only we have to employ standard scalar on the continuous variable that we have already in our model. So here, this is the data splitting part. So the data set we have divided into training and testing. 70% data we have considered for kept for training, and 30% we kept for testing. See, like X is the basically we have dropped the target variable, and Y we have kept the CSAT score and reshaped it. So again, we have one not encode I have applied on the target variable. So this is the thing. So this is the like shape of the extend white and extend white test. See, like more than 60,000 data are there for extend training of the model, and X test we have kept 25,000 to nearly about 26K data. So I have like dumped it in the features PKL file. So after like, we have kept the feature thing here into that PKL part. So after that we have to handle the imbalance part, as we already seen that our data set is imbalance. Like rating like 5 rating has more rows as compared to other ratings. So as it's as it's basically uh, like 5 rating rows or more. In that case, we have employed smart here. Smooth is basically synthetic minority oversampling technique. So as we have to oversample the technique, like we have to create other samples for other ratings as well. So that's why we have used Smooth. Smooth basically generates the synthetic samples for the minority class based on their like like neighbor features, and to balance the distribution. So that the model we are creating, so that they can learn from uh, different types of ratings. They can't like overfeed with the 5 rating. So so these are the numerical features were handled using median imputation. So before smooth, we should ensure that the continuous feature should not have any null values. So again, we did the median imputation. After that, you can see by using simple imputer, I have checked for the median, like imputed with the median values. As I already told that the before applying smooth, we have to ensure that there is no null values. So see here I have applied smooth. So and created the like oversampled the other features like 1, 2, 3, 4 ratings features, 1, 2, 3, 4 rating rows, and after that, we have one hot encoded the resampled target values. Here is the after applying smooth. Here is the distribution. You can see like all features has equal number of rows. So now the model. Now we can like go into the model building part. Here. So first of all, we have started with the baseline model. So baseline model, we have tried to set a benchmark for the our enhanced model. I would say our like parameter tuned model. So this is like I have like imported all the basic libraries that are like necessary to implement a basic deep learning model, AN model. So I have defined the like the baseline models, like the layers, activation functions we have used as a ReLU, and the softmax we have used for the number of classes here. Basically, softmax we have used because here the rating as multi-class. Like we have 1, 2, 3, 4, 5. There is multi-class. That's why we have used softmax. So after that, I compiled the model, and this is the summary of the model. And here we have started the training of the model, and you can see we got the accuracy around 68%. So after that, we have employed the like cross validation and grid search on the advanced ANN model. So advanced ANN model means the baseline model we did some improvement, like we have employed cross validation and some parameter tuning, and we have tried with grid search as well, but due to my like machines RAM issue, I did not perform that steps, but I decided to do this in future if I have the better machine. So I have did only the cross validation technique here. So basically, I have imported the Karaskil classifier from the Keras wrappers. So these are the like modules that I've imported to like apply this advanced ANN model. So I have created a one function named scheduler to like if the epoch is less than 10, then we have to return the that error. But if the model epoch is greater than 10, then in that case we have exponential. We have used exponential so that learning can be faster. And here I have defined the ANN model. Basically, there are like 5.2 layers are there. Here also we have used activation as softmax and compile it. And here also we have like as this issue, like we have imbalance, like data balancing issues, like data is imbalanced. Again, here we have used like class weights for imbalance issue, because like I have tried by without using this, but I'm getting very less accuracy. So I've implemented this. Like maybe there is some issue with the imbalance part. That's why it won't give me that accurate like accuracy. It's not like improving their accuracy. So I have used this inside the model. And let's see, like I have like wrapped the model by using scikit classifier. And here I have started with the stratified cross validation. And this validation technique, it took too much time, like nearly about 2.5 hours. And after that, we got accuracy of 75. So, like basically, I have like I saw during the training. So like the like in my case, basically this dropout rate, if we are decreasing it, and the learning rate also, if we are decreasing it, yeah, like and time by like in some time, like in it's taking too longer time, but model is learning well. Model is giving good amount of accuracy, I would say. So this is the thing. And also the epochs, basically epochs is also creating an like impact in our model. I have tried with 50 epochs. I have tried with 100 also, and I have tried with more than 150 also. So whenever I am just increasing the epochs, I am getting better accuracy. But like if I have like if I am giving more than 150, in that case my machine is like not able to handle that, like not able to handle it all time. Like the runtime is disconnecting, and again I'm starting from the scratch. So that's why I have considered 150. So if we need like better accurate model, in that case we can increase epochs to 200 as well. So I have considered 150, and I got accuracy of 75%. There is the accuracy. Just a minute. Yeah, yeah, yeah. This is the accuracy part. So I got 75% accuracy. So this is the like visualization part of the model accuracy and the model loss. This is the confusion metric for the validation fault. This is the ROC AOC curve. You can see. So after that, I have saved the model. I've saved the model as she said model.h5, and I have also implemented like Streamlit visualization. Let me open the code for installation. You can just see how I have done. See, this one is the Streamlit like visualization code I have written. Page config these things, and this is the like page that I have built using Streamlit. So these are all the base values that are already present on the Streamlit as the like default. I have set these values. So if these are the like feature that we have to give to the model, and it will predict a CSAT score based on the features. So the model is running, and I have employed like CSV upload also. So you can upload a CSV file with like with this with some amount with some rows of features, these features. So accordingly, the model will give output. I will show you that part also. Just a minute. Let's wait for this single record input. Um, let's wait for a few seconds. Taking a bit time. Let's see. Yeah, turning. Yeah. So predicted CSAT score is 1. So let's try the CSV upload as well. So we have to browse the file. So I have to go into my folder where I have kept the test file. Just a minute. Let me go it. And the user should test it. So I have included some like test data here. I've uploaded it. This is the preview of the data that I have uploaded here. So you can see all the feature value I have uploaded here. So let's see based on that how the model is predicting. We have to wait for some seconds. Yeah, the prediction has been completed. And see, based on these features, they have mention has added one predicted CSAT. So all are basically CSAT has 5. So you can download it, download the prediction as CSV as well. So that's all about my like project. Thank you.